Okay, so good morning, Pipeline.
Morning.
Yes, got a response. My name is Becky Stafford and I'm the technical lead for test automation at Just Eat. My team and I work to implement and maintain the test automation frameworks across the consumer-facing web, iOS and Android applications. I'm really interested about how I do in this talk, so please come and find me afterwards and give me some feedback. Bearing in mind Linda's talk earlier, if anybody would like any jelly beans, I'll just leave them over here. I remember the green post-its. Okay. I don't know if any of you have experienced this, but it feels to me like every time I join a new team, the speed of getting a feature from inception to production appears to have increased dramatically. I've gone from working in teams who never released to teams who released maybe twice a year, to teams who release roughly every 6 weeks. And I'm currently working in a team who release every day. Frankly, I'm terrified. Where have all these awesome high-speed developers come from, and what do they think they're doing? Honestly, I used to love my job. It was lovely and laid back, and there was no pressure to release anything ever. And if we did have to, then it was carefully thought out. All of the edge cases were thought of. It was analysed. It was reanalyzed. We tested on all of the browsers and all of the devices. It was amazing. I could hold features back from users for months, if not years. Can anyone tell me what happened to all my power? Let me take you back in time. Back to before continuous delivery was even a thing. Back to when QA was in charge. This is an example of a development process that I worked on with a team a couple of years ago. Essentially, the developers would check in over a 2-week period, any bug fixes, any features that they happened to be working on. After that 2 weeks, a team of testers would pick up the branch for release, and they would begin the real testing. This testing process would take a further 2 weeks. The total release cycle in this case was actually around 6 weeks, but I'll explain why later. So those testers would begin by deploying the code, including all of the dependent components, onto a QA environment. And they would then embark on the beautiful, amazing journey that was manual functional testing. The testing in this case was long and arduous. We had around 2 weeks worth of changes to test and very little automation to support us. We had 1,000 manual test cases and 10 high priority browsers and devices. Now, obviously, in a 2-week time period, we wouldn't be able to get through all of those test cases. So we would prioritize and cycle through them. We found ourselves stuck in a vicious cycle, whereby we desperately wanted more time to work on the automation in order to reduce the amount of manual test cases that we had to run. But the more attention that we drew to the lack of automation coverage, the more terrified management in general became that the testing wasn't sufficient. I mean, we were running thousands of tests every week and there were still bugs in production. So obviously something was going wrong. Management continually asked us to make the manual testing better and more thorough. And the very idea of doing less manual testing so that we could spend time on the automation was horrifying to them. For them, the manual testing had become a security blanket, something that was cozy and comfortable and warm, and it was something that they could rely on. They definitely didn't want that taken away from them. In this delightful process, then, what would happen if we found a bug? Well, if we found a bug on the release branch, we'd have to figure out if it was in master as well. If it was, the bug would have to be fixed and retested in 2 different places. If it wasn't, we would have to make a call whether to retrofit the fix that was already in master into the release branch. Often, it was not deemed worth the value of doing this, and the release would be pulled. But that was okay, because it was only another 6 weeks until we could deploy again. We didn't realize it at the time, but we were practicing what I refer to as fear-driven development. We were so afraid of breaking even the smallest experience that we became overly cautious and almost to the point of paralysis. The system in question was difficult to automate, and we didn't have a good infrastructure or the expertise to make that automation problem go away. So instead, we continued to enhance our comforting manual testing process to become even more complex and elaborate. In this world of FDD, even the smallest of 1-pixel bugs would be labelled as blockers. So you can see how we would struggle to release anything meaningful in this time frame. 2 weeks' worth of changes from multiple developers also made it very difficult to assess the impact of those changes on the code base in isolation, but even harder to assess the impact of those changes on each other. And that meant that making educated guesses about which parts of the system to target with testing near to impossible. The reason why this process really hurt, though, was because of the way in which we were set up to support and release the software. Deployments were really painful. To deploy to the QA environment took 30 minutes. In order to get to production, we had to go through both QA and staging. Unfortunately, deployments to staging took a little longer than 30 minutes. Does anyone want to hazard a guess at how long a staging deployment would take? Yeah, I wish. 2 weeks is how long it took us to get onto staging. The reason for this is because we had to schedule a ticket with another team who required a notification period of 2 weeks of the exact version of the code that we had to release. In order to give them this, we had to be sure that there were no blocking bugs in the release that we gave them. So towards the end of week 2 of testing, we would notify the deployment team, and 2 weeks after that, we would be on production. Now, I think I know what you're all thinking. Me too. Okay, so the new scary world. When I first joined Just Eat, we were releasing the web code about once a week. And this literally knocked my socks off. I was astounded and scared. Over the past 6 months, that same team has been working together to inspect and adapt that process in our move towards continuous delivery. We're currently releasing the front-end web code between once and twice a day. Every now and then, the second deployment is to fix a bug in the first deployment, but I'm still counting it. So what factors have enabled us to move into this new, awesome, yet terrifying place? I thought it might be useful to help you understand how our environments work before I go on with the talk, just so that you know what language I'm going to be using. So we have QA, pilot, beta, and general environments. Pilot, beta, and general are all considered as and referred to as production. We deploy from master onto our QA environment. Once tests are green, we can then move to pilot and/or beta. Pilot takes 10% of our traffic and is simply a subset of general. Once the code has proved itself overnight on pilot, it can move into general. We do not have a formal manual test process in our team. I'm aware in testing circles that this is highly controversial, and please believe me when I say I know this approach doesn't work for every company and every product. I genuinely believe that manual testing is valuable. It just happens that in our team, we choose to gain that feedback through some different mechanisms. We have a demo process. Throughout development, devs will sit with product owners and take them through the product on various different browsers and devices. As testers, when we're writing automation, we explore the functionality in the different browsers and devices to better understand the code that we're writing the automation for. Those two things together mean that we get some feedback directly into our team about how the newly implemented code is performing. Every page in our application has a feedback link, and if we're making a particularly big change, we will choose to beta it first before switching traffic in production onto it. Those two things mean that we have a really great community of people in the real world who feedback, and again, that feedback comes direct into our team, and it feeds into how we improve the product. So just to clarify, as soon as the code makes it onto the QA environment, the only thing standing between that code and production is a set of automated functional tests. The infrastructure at Just Eat is built on top of AWS. This means that every morning we spin up a new QA environment. It contains the most recent pinned builds and the most recent code that we pushed into master for all of our dependent components. Every time we push a new change into master, we build it onto the QA environment and run all of the tests. Our automated functional tests run in parallel across multiple AWS agents, and they take around 10 minutes to complete. They cover many things, including automatic JavaScript error detection, headless checks and form validation, a set of functional tests that run in a browser. We also run native application integration tests. So our native apps use some of the web views that we provide to them. We want to be sure we haven't broken them with every deploy. We also run a subset of the JMeter user journeys that run performance tests in production. So as soon as all of these test builds are green, we can release the code to production. The rule that we aspire to as a team is if it goes into QA, it's got to be good enough to go into production. In order for this to be the case, we need to push as much of the traditional testing effort as far forward in the process as we can. As a team, we ask developers to run a subset of the functional test before they commit. To help with this process, we make the tests as fast and robust as we possibly can. And developers ensure that they understand and communicate the impact of the change that they have made. Essentially, the tests need to be useful to a team. I have seen teams fail to reach a point of constant release because their automation frameworks are letting them down so badly. At any point in time, the automated test should be visible and well understood by your team, and you should be able to ask the question of them, can I go live? So here's how we ensure that our automated tests are as useful as possible to our team. Quite often in teams that I've worked on, the process of writing automated tests goes a little like this. The tester will write a feature file and commit it into the repository. The developer will write the application code and then commit that. And then following a deployment onto the QA environment, a tester will pick up that code and then write the automation against it, and then commit that. So this can cause issues. In the case where that feature later gets reverted, you would then have to dig out the test code as well as the application code and make sure that you remove the tests or disable them. And it also means that there's a risk of untested code making it into production. So our proposal in this case, and something that we've been working on at Just Eat, is to have developers and testers working on the same branch as each other to ensure that the test code, and the application code all go into the repository as one complete unit of work. So I'll be honest, at Just Eat, we haven't quite nailed this process for every ticket that we work on, but we've made some progress and we've seen some good results. The idea behind this approach is that if the tester creates a branch and commits the feature file, and then the developer can add that branch as a remote and write the application code. At the same time as the dev is writing the application code, the tester can write a best guess at the automation code, or in our case, the step definitions. When the developer is complete, they can run the tests for that feature and then pair with the tester to discuss the best guesses. Depending on how that conversation goes, they can change either the application code or the test code, or both, or neither. Once everything is ready, a pull request can be created with all the code in it as a single unit of work, and it can all be reviewed and then merged together. In this way, we found that the tests and the code can live and die together and can be reverted or deployed together as necessary. So there's some other things that we do to make sure that our automation is as useful as possible to our team. We like to keep the barrier to entry for our automation tests as low as possible. If someone on your team finds it hard to locate, set up, or run the automation, then they're most likely just not going to bother, and that means that the tests are not going to be useful for them. In our team, we maintain a zero-tolerance approach to flaky tests. If a test fails, we delete it. Our reasoning is that lost my place. Hang on, bear with me. Our reasoning for this is that if a test fails and there isn't a bug in the application, the test is giving you bad information. I've definitely written or owned test frameworks where when a test failed, I spent a few hours digging around in the test code trying to figure out what I'd done wrong with the test. And after a couple of hours of this digging around, I finally came out of the test code, bothered to look at the application and realized that there was a bug in the application. I had a little victory moment. My test found an actual bug. Just to be clear, if you are ever pleasantly surprised that your automated test has found a bug, then you may already have an issue with how useful your automation is. We are occasionally more lenient. If we think a test is worth the fix, we will quarantine it and then fix it. If we do have 3 releases where that test hasn't been run, then we will tend to delete it. Because with 3 releases going out the door without that test, it's probably not worth the fix. Speed of test execution is incredibly important for useful automation. For our team, the tests have to be able to run in under 10 minutes to be considered a viable set of acceptance tests. In order for this to be the case, we have to be a little creative with our tests. We constantly inspect our tests and we monitor our application. If there is a particular area of the application that we believe is stable, we can reduce the number of tests that we have running there. We can also dynamically alter the tests that we have running. As a team, we communicate. We ask questions to get a better view of the impact of changes that are happening on both the application and the underlying platform. And then we can enable and disable those test builds as and when we need to. We make as many of the tests headless as we possibly can. We don't see value in running every single functional test in every single browser. Another way that we ensure our tests are useful is to ensure that we have high test code quality. I used to be of the opinion that measuring test code quality was completely pointless. And then one day, a very dear colleague of mine suggested that I might want to measure the quality of my test code. Now, obviously, my Ruby was amazing. But to humour him, I found a tool called Rubocop. Rubocop does static code analysis across Ruby. When I ran Rubocop, I found that there was over 5,000 ways in which I was offending the Ruby community. And surprisingly, when you write your test code in an efficient and clean way, your tests run faster and become easier to maintain. My colleague was right. So that was a little bit of information about how we make sure that our automation is as useful as possible to us. I'm now going to talk a little more generally about other things that we're doing as a team to help us move towards continuous delivery. When we're developing a new feature that cannot be rolled out incrementally, we will use feature toggles to control access to that page or new feature. This means that at any point in time, there are multiple flows through our code that users could be seeing. In terms of testing, even though the feature itself may not be production ready, we still care for the code behind that feature toggle, and we like to consider the code as production ready. At an unknown point in time, product will make the decision that that feature is ready to be released, and that toggle will be enabled. So we need to be ready for when that happens. It also could be that the toggle is accidentally triggered, so we don't want to be completely ashamed of the code behind it, but just to be clear, that has never, ever happened to me. So taking the Just Eat search results page as an example, this is a page that already existed for us, and we recently chose to rewrite it and bring it into one of our new responsive repositories. The rewrite involved some new functionality. So initially we captured those scenarios and put them into our feature files. We already had some tests for the old search results page, so we duplicated the valid scenarios and brought those into the new feature files as well. We tagged the tests so that we could identify the old tests and the new tests, so that we knew which ones to remove once we were fully rolled out. We added a new step to the new scenarios to set a variable and trigger the feature toggle so that we could access the new version of the page. We used the same step definitions for both the new and the old page, but we had an if statement to trigger different test code depending on which page was under test. And this approach allowed us to ensure that both flows were fully tested. So as we were making improvements to our process in our move towards continuous delivery, we realized that some of our tools were holding us back slightly. Our Agile board, for example, was shaped around our process, like this. So you can see that this would lead to bad behaviors in terms of doing testing after development. It also gave us a sign-off column, which enabled us to have a bottleneck, a lovely place where tickets could sit, waiting for product and UX to sign them off. We changed our Agile board to look a little more like this. So we flipped it from focusing on our process to focusing on our environments. What this means is that we renamed in dev to in progress to remind us that anybody from any discipline can be working on tickets in this column. We no longer had a sign-off column, so the tickets couldn't sit there for days anymore. Instead, we auto-transition as soon as a ticket comes into QA. With every deployment that we do, it auto-transitions through the columns. We no longer had a place for QA to happen after development, so it forced us to push our effort forward in the process. And it's now a case of either you do your work up front in the in progress column, or you watch the board like a hawk and try and catch the ticket when it's on QA before it goes out into pilot, which with 2 releases a day is quite difficult to do. So earlier I asked you what had happened to all my power. I was mostly joking. The power of deciding whether a release is ready to go now sits in Team City, with a set of test builds that we entrust to do that job for us. That power also now sits with our engineering team as a whole. We need to keep each other honest, and we need to challenge each other. We can ask questions such as, have you demoed this? Have you run all the tests? Is there any test code in this pull request? So these are the techniques that we've used at Just Eat to help us move towards continuous delivery. We're definitely not there yet, and there are things that we need to work on. But I hope this presentation has given you some ideas around how you can adapt your testing process. That's the end of my presentation. Thank you for listening. Does anyone have any questions? Yes.
How do you cross-browser visual testing?
How do I, sorry?
How do you do visual testing?
As in looking for UI defects? We don't. We don't at all. So I mentioned that we get that feedback from other places, such as our general community of people that we release to. They feedback straight into our team, and we explore that. We explore visually what's happening when we're writing automation, but we don't have any formal visual testing. Yeah.
You mentioned you've got a pilot environment and a beta environment.
Yeah.
What was the beta environment?
So the beta is for when we've got a particularly big change that we want to release to a closed community of trusted people. Pilot is just a subset of production, so that's just 10% of our live audience see. Any other questions? Yeah.
What's the skill set of the people writing the test?
The testers are all engineers. I use the word tester very loosely. Any other questions? No? Thank you very much.